previously on that. Well, let me get started here because I know there's a lot of things on the plate tonight. This is a presentation that was in part presented by our VP of Engineering, Tony Montero, during the Hamvention Forum, so maybe some of you have seen this before, but since most of you are probably working, you probably haven't. So if we could have the next slide, Steve. What we're doing in the satellite world is we're really kind of facing reality, because in the years past we've been able to have launches given to us in some cases, or at a very low cost, to get our satellites in orbit. Usually what we'll do is we'll seek out a new launcher or a new rocket that someone is providing, that someone with a multi-million-dollar satellite doesn't want to put this multi-million-dollar satellite on. So they'll come to an organization like us and say, hey, would you like to ride? We'll give you a reduced ride, or in some cases, no cost ride. And we've been very fortunate over the years in that strategy. Sometimes we ended up in a sub-Atlantic orbit. Other times we actually got our stuff into orbit. So unfortunately what's happened is in some ways we've become the victims of our own success, because space now has become commercialized and it's very expensive to get launches. So what we're trying to do is to get another what we call a high altitude launch, where we get a satellite up into a very high orbit, where you can kind of point your antenna at it for hours at a time and communicate through half a hemisphere. Well, unfortunately, those launches now are in the tens of millions of dollars, which is way beyond anything that an organization like AMSAT can do. So about 3 years ago, we put our heads together and said, well, what can we do? And what's happened is there's a whole group of satellites that are coming along called CubeSats. These were, if you will, the brainchild of another AMSAT member who was working at the university, or at Stanford University, and had done some work for us on the AMSAT side. Professor Dr. Bob Twiggs, he and a colleague got together and said, you know, with the advancements in technology and the shrinking size of components that make such things as our cell phones possible, we could maybe do that with satellites and kind of get the same performance out of the satellite that's fairly small, but at half or 3/4 of the size. So what we've done is we're changing our strategy to take advantage of these kinds of CubeSats, so small little CubeSat things. Fox is the latest satellite in this series for us. We've gone through Alpha, Delta, Bravo, Charlie. The last one we had was Echo, that became AO51, which is a very popular FM satellite, which unfortunately its batteries died on us here about a year ago. So Fox is being set up as the replacement for that, but instead of a satellite that's like this, we're now going to put everything into a satellite that's like this. This is full size. If you can believe that we're putting all of that capability into a satellite that's this big. So that's where we're headed. What's also happening is in the rest of the world, a lot of other organizations, predominantly universities, are getting interested in this same thing. So what we're talking about is saying, hey, let's see if we can collaborate with some of these other organizations, like universities and educational institutions, and see if maybe between the two of us, we'll be able to launch some of these CubeSats, maybe at low or in some cases no cost. And that's precisely what's happening. And what we're finding is a lot of these universities with their aerospace education departments have a whole lot of theoretical knowledge, but they don't have the hands-on experience of actually building and launching space hardware. Because you have to stop and think about where we're operating. You know, most of us have our ham radio stations. We have a fan, or we have a heat sink on the back of our radios. Well, that works fine when you've got air. But when you put something like this into orbit, when it's in the full sun, it's baking at about 250 degrees Celsius. And then when it goes behind the Earth, it's freezing. at minus 250 degrees Celsius. And that changes every 45 minutes. So just imagine if you put your HT into this, imagine how long it would last. Probably not very long. And that's been what's happened is that as these universities and so forth have gone and they built lots of these things, they don't have the experience that AMSAT does in actually building and launching spacecrafts that last for more than one orbit. Oops, hello. Back up. Here we go. Anyway, so what we're doing is we're partnering with some of these organizations to see if we can maybe get a low or a no-cost launch. And what's usually happening is we're saying, look, you've got an educational mission, you want to do some science, you want to sample the environment of space, or you want to see how your satellite is stabilized. But after you're done, how about turning it over to us hams? And so that's the other part of this. It's the old, you scratch my back, I'll scratch yours. We'll help you build your satellite, lend our volunteer expertise to you, and in return, once you're done with your satellite, hey, can we have it? So that's kind of what we're doing. Next slide, please. So for Fox 1, we're basically here just going to be building a replacement for AO51, which is what we call a bent pipe transponder. That is, whatever you send up to it, comes back down in the same way. If you send FM up to it, it comes back down as FM. These are crossband, essentially crossband repeaters in the sky. The first mission, we're also going to be combining our experience with Penn State. They're going to have an experiment on board. The launch has already been secured, again, because these little satellites are starting to become something that people would like to be using, including, by the way, the military. We're getting interested in this. What we'll usually do is, and it carries a concept that we've had for many, many years. You can see this. There's also a poster over here on the side. But you see, those are all circuit boards. And usually one circuit board will be a receiver, one will be a transmitter. We'll have one board will be where we're going to stick the batteries. And then there's usually a couple of boards that we leave blank for a concept we call TSFR, this space for rent. And so what we're doing is we're leaving space deliberately inside our Fox design so that organizations, universities, and so forth can fly their experiment. We have a launch target, which we're looking at the second half of 2013. Let me just speak a little bit about this Atlanta program. Again, because NASA is starting to get interested in this whole concept of CubeSats, they're looking to launch basically for free a CubeSat if it meets some of their educational activities, some of their goals that they'd like to achieve in space. And so again, we're piggybacking on that idea. By the way these things are launched, they're pushed into a pod, which they call a P-pod. And sometimes you'll have 2 or 3 of these things inside this little cage. There's a spring on the bottom and a little door on the front. And when it's ready to launch, the little door pops open and out pop the satellites. Very high-tech stuff. Anyway, a follow-on mission which we'd like to be looking at is called Fox 2, and here we would be flying a software-defined transponder. By the way, our AMSAT satellite, which some of you may remember was tossed overboard, literally tossed overboard on the International Space Station, was the first software-defined transponder to ever fly in space. And that was something that our AMSAT volunteers did. And then hopefully for some follow-on missions, we'll have some linear and digital modes to actually operate with as well. Next slide, please. So, essentially for Fox 1, we're going to be looking at an FM repeater, it'll be a crossband repeater. We're going to go up. The uplink will be on 70 centimeters. The downlink will be on 2 meters, FM. We're also going to have a telemetry experiment on board so that we would send some FSK down. And this is more or less an experiment just to see how well this concept works. The command mode will be in the high-speed data activity, 9600 BPS. And we're also looking for some high-power data requirements where the reason we're doing this is to kind of get the concept of this, of what we call the bus, the actual satellite working, so that if somebody later on comes and knocks on the door and says, hey, I need something with 9600 baud downlink for information, we can say, yeah, I've done that, been there, done that. And yeah, we'd like to help with it. Okay, next slide, please. We're also putting a feature into this satellite which we call the zombie sat. One of the problems that we've had in the past, and it's not unique to AMSAT, but in particular, the long pole and antenna on all of these satellites are batteries. And in particular, with the FOXSats, or with the CubeSats, the big problem has been they tend to run cold in orbit. Remember I was telling you that it goes from 250 degrees Celsius in the sun to minus 250 degrees Celsius in the shade. How many of you have ever tried to take pictures with a digital camera when it's about 20 degrees below zero? Doesn't work, does it? Oh, Don has. Doesn't work very well, does it? That, unfortunately, is one of the big problems with these small satellites, is keeping their little innards warm so that the batteries will take a charge and actually work. Now, there's a couple of other things that we're looking at in relationship with our good friends at the State University of New York. We're experimenting with, instead of using batteries, we're experimenting with a concept called supercapacitors. Has anyone heard of those? Okay. Supercapacitors. Looking at, instead of, and these things are about the size of an A cell. Looking at a supercapacitor instead of a battery. That is, they're now making these capacitors where you get maybe 12 or 14 volts, or 1.2 or 3 volts with a 250 farads of charge. Now, when I was growing up, a farad capacitor would sit on a flatbed truck. Okay. Now, it's shrunk down, and so we're looking at possibly using those. The other thing we're going to do for Fox, though, is that we will probably wrap the batteries and maybe use a little heater in there to keep their little bottoms warm when they go into eclipse. The other thing that happens, as I said, though, is that invariably our batteries tend to fail. This is what happened with Oscar 40, which was phase 3D. It happened again to Oscar 51, and it even happened to Oscar 7. How many of you remember Oscar 7? Okay, a few hands. Oscar 7 was launched back in 1974, and it died about 1981 because of battery failure. Well, somewhere between 1981 and about 1996, one of the batteries, instead of shorting out, opened up. And lo and behold, a friend in England was listening, and all of a sudden started picking up this beacon. He said, boy, that sure sounds like Oscar 7. Well, absolutely, it was. And so now Oscar 7 is actually back in use again, because when it's in the sun, it works. When it goes behind the Earth, it doesn't. We're saying, you know, we probably ought to build that into our satellites. So that's what we're doing, is we're designing Fox 1 so that we're planning on, if you want to call it planned failure, we're planning on the battery to fail. And this will also allow us, once the battery fails, if the satellite's in the sun, it'll be on. When it's not, it won't be. So, and the same thing will happen with the computer. It's designed so that the internal housekeeping unit, which is a $10 word for the onboard computer for the satellite, will also, the satellite will work without that as well. Okay, we do have one science experiment we're going to be flying with Fox 1. It's a Penn State experiment. They're basically going to have some gyro sensors on board in that TSFR place I was talking to you about. And they're going to be measuring the spin, the direction, and the wobble about the magnetic axis. It was actually that experiment which helped us get NASA to fund the launch under this Atlanta program. It was a key element of them picking us for that launch. Now, we still don't have a firm launch date because it depends on where they're going to be, how many other satellites are going to be launching. We're in the queue, and we're looking at hopefully sometime in 2013 to be able to fly. As far as Fox 1 is concerned, we had our concept of operations completed in September of 2011. We did a systems requirement spec on it in October 2011. We applied to NASA in November. We were accepted in February. We did a PDR in April, and that was all done online, by the way, using this GoToMeeting concept. It's fantastic. We were able to have a complete preliminary design review, all done on the internet, where it used to cost us several $1,000s to get everybody together. We were able to do it that way, so it's helping us to conserve our meager resources. And we're currently in the process of working on the first engineering prototype. Next slide. Here's just a basic block diagram of what Fox is going to look like. We've got a 70-centimeter antenna. Essentially, it's going to be a little stub that comes off of one corner. The 2-meter antenna will come off the other corner on the bottom. It'll be a good old 19-inch whip. Nothing more than that. We have power coming from the solar panels, power coming from the battery, going to the bus. The IHU is our onboard computer. The science experiment will be working with that. There'll be some kind of an attitude control input. Then the RF system will take the uplink, run it through the transponder, and send it down and down. Next chart. This is a block diagram, our artist concept of how the satellite's going to look. You see the batteries tucked in here. These are A cells, standard NiCads. They're just going to be tucked in there again. We're probably going to have to wrap them to get them nice and warm. And again, if you want to come over after the meeting and take a look at this model, I'm going to have it over on the side here. Next slide. Our space frame is high-tech bent aluminum. We're kind of like Dara, we're equal opportunity exploiters. We build a lot of this stuff literally in garages and basements with leftover parts. In fact, I was on the radio with Ted Randall, who was out here at the ham bench, and I made the comment that there's, right now, as we speak, there are parts that came out of the Dayton flea market that are in orbit on Oscar 40 and will be there for the next 4,000 years. Dara even has, if you were talking about the world's greatest club, you can say that you also have a piece of Dayton in orbit. In fact, there were some pieces also came out of Mendelssohn's downtown. Very much a Dayton satellite. In fact, I don't know, there's another story that if you remember Ron Paris, who was a satellite or an astronaut, there are a lot of ham astronauts and astronaut hams. But Ron was your, I think he was your ham of the year one year. He was one of your award winners. And when I was here stationed, someone asked me to help squire him around because he was part of AMSAT. Anyway, Ron is a ham astronaut. He was a ham long before he became an astronaut. Unfortunately, he's a silent key. Just a super guy. But anyway, this was about the time that NASA decided to fly U.S. astronauts on the Mir space station. You all remember the Mir space station? It was the Russian. This is when we were doing, hands across the water and all that. Well, the problem was the Mir was in such a low orbit that they could only communicate with it for about 15 minutes over Moscow once a day. And NASA said, no, this will never do. So we have to build some ground stations for NASA to be able to communicate with it so we can talk to our guys. One at Wallops Island and another one out at White Sands. Well, I don't know if you remember, but the communications frequencies for the Mir space station were just below 2 meters. It was like 143 something. And I can remember leaving my radio on that frequency, and occasionally you'd hear these guys come over once we got the station set up. But anyway, Ron flew in, we're walking through the flea market, and he was working at the time for a contractor that had the contract to build the ground stations for these two ground stations, one at White Sands and one at Wallops Island. $10,000 a piece I think it was Gates or Collins equipment, good heavy stuff. He's walking through the flea market, and he looks at one of the vendors, and there's 2 of these radios underneath. And so he looks and he says, "How much you want for them?" He says, "Oh, about 150 each." Sold. Make a long story short, the 2 radios that NASA used to communicate with the Mir space station came out of the Dayton. So, there again, you see, we do have talking about a far-reaching effect on things. Anyway, here's what Fox is going to look like when it's assembled. Again, we'll have magnets. We're going to have some magnets in the side to keep it stable when it spins. We're also probably going to put a little bit of gold foil around the area where the solar panels are to keep it somewhat warm. If you've ever seen satellite or big satellites, they have this gold foil stuff. That's designed for thermal control. Next slide. We also we've kind of gone from famine to feast here. There's another proposal going through, in fact, there's several proposals going through under another project that NASA's using called the Edison Project. And what they're looking at is to design some technology for these small satellites and actually demonstrate it. If you happen to be one of the groups selected, they provide the funds to both construct and launch the satellite. AMSAT has partnered with 3, count them, 3 partners with these proposals that have gone into NASA. We were accepted to proceed to the next phase in all 3 of them. So what this means is that if NASA selects one of our partners, essentially AMSAT will be working as a subcontractor. If NASA accepts the main group's proposal, then we might also get not 1 but 3 satellites out of this, hopefully. But because it's a very competitive process, we're not expecting that all 3 are going to go. We may end up with none. We may end up with 3. We don't know. And we really can't talk about it because it's still in the competition phase. We did submit the proposals, or actually the primary proposal person did submit something to the 22nd Bank, and so we're expecting maybe by the fall we'll know one way or the other. So the future is very bright because of these little things. And at some point, we may be able to have several of these things in orbit, and as one kind of sets, you turn your antenna and go talk to another. And we also have another opportunity in the Atlanta program coming up in August to see if we can do a follow-on mission there. Next slide. Have any questions? Yes, sir.
For a proof of concept.
Yes, sir.
Every time we put one of those little boxes up there, it stays up for a long period of time. It's dangerous. Did you find a way to wrap the Mylar balloon around it when it dies? Did it inflate and push it out of work?
That's good. That's one of the things that we've been talking about. In fact, of course, power is another issue. And I made a proposal for a 20,000-mile extension cord that didn't go in. But yeah, I mean, that's the kind of stuff that these guys are looking at. It's really kind of fun to sit on these conversations because there's lots of stuff happening. In fact, there was a lot of stuff going on right here at Cambench not more than a couple of weeks ago because a lot of our engineering guys are here. And they're sitting down at the breakfast, drawing on the back of napkins and everything else. So, yeah. The orbits that these are going into are about 450, 500 kilometers. We can't go any more than that, any higher than that, because we have a degree mitigation issue. Because if it goes more than 25 years, we have to have some way to bring it down, because space is starting to get filled with junk. And, basically polluting the space. So, but if it's 400 kilometers or less, usually it'll come in within 10 or 15 years. We're designing these spacecraft to last a minimum of 5 years. Yes, sir?
You talked about using night CAD batteries.
Yes, sir.
In electronic travel, I'm trying to go to either lithium or nickel metal hydride or night CAD. Why are you using that technology?
a lot of discussions about possibly using other things. The NICADs are proven to work in that kind of orbit for the most part in terms of the environment. We thought about nickel metal hydride. The other issue we have to remember is that we're hooking a ride with somebody else, and there's a qualification process that you have to go through with batteries in order to fly on a NASA mission. In fact, sometimes we say that the paperwork associated with the launch has to weigh 15 times the weight of the satellite because of all of the issues that NASA deals with. So yes, we've thought about nickel metal hydride, we've thought about all kinds of other lithiums and so forth, but as it stands right now, the only ones that we're rated for are NICADs. It's going to be but that may be an experiment down the road to say, hey, we want to fly some nickel metal hydrides or lithiums or these supercapacitors that I was talking about. Yes, sir? Yes, in fact, that's another issue with Fox. The orbit that we're going to be in is probably going to be right through the Van Allen belts. So we're probably going to be looking at radiation-hardened parts. And that may be a part of the experiment. Yes, sir?
Yeah, Keith, why don't we ever do a geostationary type of a thing?
Cost.
Okay.
Pure, plain and simple. Tens of millions of dollars, even to ride as a piggyback. The problem that you run into with going on a geostationary mission, first of all, is the launch. And then even if you were going to fly with, one of the big TV satellites, the big issue there is station-keeping propellant. The TVs, how many of you have a satellite dish? Okay, you set it up, you leave it, right? You don't have to turn it, you don't have to move it. Problem is, when they put the satellite out at that 22,000-mile point, the Earth, the Sun, and the Moon tend to chink the orbit. And so if left to its own devices, eventually that satellite will appear to get this bigger and bigger arc until such time as you have to go move your dish.
I understand. So
what they end up doing is they put propellant on board these great big satellites to keep the satellite where it should be. Well, when they put propellant on board, they don't have any room for folks like us without charging us big bucks. So it's, for the moment at least, it's off the table. Not to say that we aren't knocking on a lot of doors, because we are. And there's a lot of startup companies like this SpaceX, which you may have heard, that just recently came back from the International Space Station. There's a possibility at some point we may be able to get another one of our AMSATs up to the ISS on board one of these. But it's just cost prohibitive.
Understand.
Yeah. Yes, sir.
Keith, that AMSAT-1, were you able to gain a lot of information from that?
Absolutely.
That's helping you with the Fox?
Absolutely. In fact, a lot of the same team members that put AMSAT together were part of the Fox team. The software-defined transponder, for example, was proven on the AMSAT. So yes, yes, sir. Okay, I'm not sure I understand your question. Are you talking about numbers of satellites in orbit? A whole constellation?
Yes.
It'd be nice if we could do that. In fact, that's one of our goals, is at some point to be able to have a satellite above the horizon, an AMSAT satellite or an amateur satellite above the horizon, 24/7. Yeah, that'd be great. But see, there again, we're kind of coming to these launch agencies with empty pockets and saying, hey, we don't have a whole lot of money, but we've got some expertise and we've tried a few things. Hey, can we ride on your rocket? Again, we've been very successful going to orbit on new rockets. Well, there's not that many new rockets coming out. Anyone? Any other questions? Yes, Tom?
What's it going to take for a ground station?
We're hoping, the plan is, now this satellite, if you can believe it, is going to be transmitting with a whopping 400 milliwatts. Okay? That's basically what we've used in all of our low Earth satellites. Oscar 51, for example, is usually less than a half a watt.